Good morning, students. I'm Visweswara Rao, sir. Today I'm continuing organic chemistry. Coles electrolysis now. So, what is this Coles electrolysis? Coles electrolysis is used to prepare higher alkanes. In this case, the starting materials are carboxylic acids. What is the carboxylic acid? Carboxylic acid is nothing but RCOH, that is carboxylic acid. Carboxylic acid is also written as like this. Now, this is carboxylic acid. If R is big, that means R is a long chain. Long chain means it is having lot of carbons. It is nothing but called fatty acid. That is called fat. Okay, fatty acid. Sodium salt of carboxylic acid or sodium salt of fatty acid. Sodium salt of fatty acid or carboxylic acid. Sodium salt of fatty acid is nothing but RC double bond O. It is OH. This is acid. Acid means O minus H plus. Okay, reacting with the base Na plus and OH minus. Acid base neutralization. This is nothing but acid base neutralization. Acid base neutralization means we'll get a salt formation. So this is nothing but sodium salt of carboxylic acid and water. So this is our starting material. So sodium salt of carboxylic acid is our starting material. We have to electrolyze that one. Electrolysis you know already. I detailed explained electrolysis procedure. Electrolysis carried in the electrolytic cell. So I'm writing the basic reaction. Let me write the basic reaction. 2 moles of sodium salt of carboxylic acid dissolved in water. That means a concentrated aqueous solution of sodium salt of carboxylic acid is electrolyte. Electrolyte means what you take in the carboxylic acid is the electrolyte. That means what you are taking the electrolytic cell. Reaction, it is also named reaction. Kolbe is the scientist name. Okay, Kolbe, very, that means a pioneer, starting organic chemistry, first compound. The first compound synthesized is, urea by Wohler. The second compound synthesized by Kolbe. So, long back. Concentrate aqueous solution of sodium salt of carboxylic acid is electrolyte, and you are carrying the electrolysis. You carry the electrolysis means you will get higher alkane or R. See, this is R, and this is nothing but R. So that's why you are getting alkane. This is higher alkane plus, and you will get carbon dioxide, 2 moles of carbon dioxide plus 2 moles of sodium hydroxide plus 1 mole of hydrogen gas. These are the products. So you will get this one. That means that way what I say in electrolysis means definitely anode is there, cathode is there. Na? So that's what I'm telling. So you will get this alkane and carbon dioxide anode. These are the anodic products. And these two are cathodic products now. Right. So with this reaction, you don't have any clue. That means how reaction is going on. If I give only this reaction, student has to by heart. Okay, student doesn't know what is going on here. Now I will give the memory technique. Memory technique means that is not mechanism now. That is the easy way to by heart a chemical reaction. Definitely that helps to remember, memorizing the chemical reaction. So I will give memory tip now. That memory tip means I will write the same chemical reaction so that you can memorize for long time. For long time you can memorize now. And this is nothing but sodium, salt of carboxylic acid. And this is nothing but sodium salt of carboxylic acid. Here I am taking water and this is nothing but water. And electrolysis, Kolbe's electrolysis, same thing now. But how I am going to write here? See, I will do like this. So I'm doing like this means you can use NaOH, NaOH, 2 moles, hydrogen, 1 mole. So 2 moles of NaOH, 1 mole of hydrogen at cathode. But you don't know how they are coming at cathode. You don't know that. I will explain that one also. Don't worry. So next one is nothing but COO goes out as carbon dioxide gas. This one also goes out as carbon dioxide gas. That means 2 moles of carbon dioxide. Then what you left with, Nana? You left with R and R. This R and R form a bond. You will get this one at R. So with this, you can memorize the chemical reaction. That means no difference between this one and this one. Both are same, but you memorize the chemical reaction for long time. Now, in this case, that means in Urju reaction, I didn't give the mechanism to it. I did not give the mechanism. Because mechanism is not well established there, and you don't get any question on the mechanism of Urju reaction. But Kolbe's electrolysis, you definitely need mechanism. And mechanism is important both in physical chemistry and organic chemistry. You may get questions on mechanism. And first of all, you have to understand. So we'll leave the question part. First of all, you have to understand how you are getting anode, higher alkane carbon dioxide, how you are getting at anode, how you are getting these things at cathode. You have to understand that one. But memory technique, don't neglect that one. That means that is really useful. So in by holding the chemical reaction, of course, you need the mechanism also. That also I will discuss, madam. Simple electrolysis mechanism. You already know how electrolysis is carried, electrolysis mechanism, or detailed discussed now. Okay. So first of all, 2 moles. You take 2 moles. That means this is nothing but ONA. Otherwise, I will explain the mechanism by taking an example now. Okay. Here I will write an example. So first example. Yeah, higher alkane. That means you are getting higher alkane. Instead of R, I will take methyl group now. This is nothing but CH3COONA. So what is this one? It is called sodium acetate. Sir, what is sodium acetate? Acetic acid. CH3COOH is acetic acid, sodium salt. 2 moles. And 2 moles of water. And electrolysis. This is nothing but electrolysis. I am carrying the electrolysis. Because here I taken methyl group. Because you taken R here, you are getting R and R. Because I taken methyl group here, I will get methyl and methyl ethane, higher alkane. I taken methyl group there, 1 carbon. I am getting 2 carbons alkane. Okay, similarly to the Urju reaction. And carbon dioxide, 2 moles of carbon dioxide, 2 moles of sodium hydroxide and hydrogen gas. So these are at anodic products, and this is nothing but a cathodic product. I will use a memory tip also. That means the same thing. That means say I will copy this one and I will paste here. That means I'm copy and I will paste here. Only thing is I have to write here instead of R, I have to write CH3. That's all. This is the sodium acetate. Okay. Instead of R and R, I have to write CH3 and CH3. That's all. It's over. Ethane. So this is the chemical reaction. Sodium acetate, aqueous solution, dissolved in water. It is a salt dissolved in water. And carried the electrolysis, we will get the ethane. So this is new bond formation. That means there is a new bond forming between the 2 carbons. I will take this example to explain the mechanism. You feel more comfort now. Yes. The more comfort means you are really seeing the compound. Na? So this is nothing but sodium acetate, CH3COONA dissolved in water. So carried the electrolysis. Carried the electrolysis means, don't worry, I will take 2 moles and 2 moles. Okay. First of all, what happens? Ionization occurs. That means CH3, C double bond O minus. plus 2Na plus. Water is not undergoing any ionization. Water do not undergo any ionization. No, water never do H plus and OH minus in the electrolysis. So many times I told you. Here also I'm not doing. Only salt is undergoing ionization. Sodium chloride you dissolve in water, na, you will get Na plus and Cl minus. Na. Like that, sodium acetate when dissolved in water, you will get acetate ion and Na plus. Okay, number. So you got this one now, right? Now I'm carrying the electrolysis. Yeah, anode. What happens at anode? Anode means oxidation. Oxidation means anion. So what is the anion? The anion is nothing but 2 moles of acetate ion. So I will write the electrons also. That means oxygen 3 pairs and 1 negative charge. That is the electronic picture also I will write now. So oxygen electronic configuration. Sir, why sir? That means you just see electronic configuration of oxygen 2 pi y1, 2 pi z1. So it is having lone pair. So you can see the lone pair, this one. Another pair, lone pair. This is another lone pair. Using this electron, it is forming sigma bond. And only one bond is there. So one electron is used to form sigma bond, but it is still having one electron. So that electron I return. You are getting negative charge because this electron is taken from sodium. So because it is taking one electron extra from sodium, this electron negative charge. Sodium losing electron, that's why positive charge. Clear, Nana? Very clear. Now it is trying to, Visweswara Rao, it is asking me acetate ion. Visweswara Rao, I am having all the qualification to undergo oxidation. Let me do that. But what happens here? Water is there, na? It comes in counter. Visweswara Rao, what about me? How about me? How about me? What Mr. Visweswara Rao, water is asking. So now there is a combination. So water is trying to undergo oxidation. It is trying to undergo oxidation. Acetate ion is also trying to undergo oxidation. There is a competition between water and acetate ion. Recall the electrolysis principles. That means I clearly told you there, SO4 2 minus, PO4 3 minus, NO3 minus. These anions are competing with water. Anion means it loses electrons. Electrons losing electrons means oxidation. That happens at anode. These anions competing with water means water wins. Water undergoes oxidation preferentially than these anions. For all other anions, water is not winning. So definitely acetate ion is not here. Na? So if there is a competition between acetate ion and water, which is winning? Acetate ion is winning. What a beautiful chemistry now. So acetate ion is winning means for water, it is sorry water, you are not winning in this game. And acetate is better to undergo. That means I am putting into marker. No oxidation. I will clearly write. No oxidation for water in the presence of acetate ion. So acetate ion. Oxidation means one acetate ion loses this negative charge I don't want. Negative charge I don't want means one electron is taken from sodium, one electron is taken external. This electron it has to lose. 2 moles losing 2 electrons. 2 moles now. Here 2 moles I taken. Losing 2 electrons and you will get 2CH3 C double bond O 2 pairs 1 single electron. You see the electronic configuration on 1 pair na, second pair na, single electron using to form this bond na, 1 single electron is there. That is just oxygen. Here you are getting negative charge because it's taking extra electron from sodium. That's why sodium plus and this is oxygen. Oxidation happened. So you got this one. But having the single electron here, it is not stable arrangement. It is not stable. So because that is not stable, it undergoes quickly. Next step, I'm writing the same thing now. C double bond O, 2 electrons, and that pair on a single electron. Now what happens? Out of this bond, you see this bond. That bond I'm taking. One electron is coming from this carbon, one electron is coming from that carbon. But what happens now? One electron comes here, you see arrow mark with off head. Arrow mark with off head means definitely one electron is moving, okay? So one electron is coming here and one electron is going to this carbon, okay, Nana? And this electron is coming here. So one electron from here, one electron from here, two electrons to form a bond. Now, this bond is no more. This bond is undergoing homolytic fission. That means out of the two electron, one electron is taken by carbon, one electron taken by this carbon. So what you get? You get two CH3 single electrons, methyl radicals, plus this electron making a bond on a carbon dioxide. That is how you will get carbon dioxide at a anode. How many Nana? Here 2 moles are there, na? That's why you will get 2 moles of carbon dioxide. Balancing the equation is very important. So once you got that one, 2 methyl radicals, next step. Now I will write 2 methyl radicals separated. That means methyl radical and another methyl radical. Now there is this electron shared between 2 carbons. You will get a CH3 bond CH3, that is ethane. Yes. So at anode, what are the products here? Carbon dioxide and ethane. Anodic reaction is over now. Now come to the cathodic reaction. You have to understand cathodic reactions. So what happens now at cathode? Cathode means cation. So reduction. At cathode, reduction occurs. What happens now at cathode? What is there at cathode? Na plus is now ready. So it's some makeup. It is putting some makeup on it. Na plus is telling me, sir, I'm ready for reduction. Okay, Na plus, you are definitely eligible. Why it is eligible? It is cation. It is trying to take electrons. Okay, it is ready now. Take electrons. But there is a problem. What is that problem? This water fellow causes problem. So water fellow tried here for oxidation, but it is not winning here. And acetate ion is undergoing oxidation, but reduction, Na plus is trying to undergo reduction. But water is also 2 moles of water is also undergoing, it is also trying to undergo reduction. Then what? I told you that means recall the electrolysis principles. Chopper metals, I told there now, chopper metals. Sir, what is chopper metals? Chopper means in Telugu fish. That means in English you can. Chopper is Telugu word now. It is Telugu word. And in English, that means fish. You eat fish, na? Like. So, chopper metal. So, what is chopper metal? This is copper. And this is nothing but mercury. And this is the first year is nothing but silver. And this is nothing but platinum. And this is nothing but gold. Chopper metals and water in competition. Chopper metal win over water. Chopper metals undergo reduction preferentially than water. All other cations, all other metals, water only is winning. So it is not chopper metal, it's Na plus highly metallic. Okay. So in this case, water is winning. Highly metallic means Na plus having the inert gas configuration. It's very difficult to, Na plus reluctant to take electron actually. Okay. It is already satisfied with inert gas configuration. Like that also you can understand. So water is winning. So I will put no reduction plus no reduction for Na plus now. No reduction for Na plus. Water takes the electron. This chopper metal, I think already given, Nana. Already given in our that electrolysis thing, Nana. But somehow you may forget that win over water in reduction. Okay, I will keep that one now. Okay, I decided to keep this one here. I will keep this one here as a side note. Right. Now water is taking electrons. How many electrons last year? Nana? 2 electrons are lost in oxidation. Na? The same 2 electrons are taken. The same 2 electrons are taken by water. So how to write that means these reductions are water if takes electrons, what are the products are? I forgot. So generally students generally tend to forget. Nana. So long back, once you revise, you will immediately get the picture. That means long back I studied that. I not revised because of my examinations and weekend syllabus. So I am getting this one. So H plus and OH minus, right, Nana? So two moles, for example, one H plus and one OH minus. Write water like that. It takes electrons and forms hydrogen gas. And it is as it is there as OH minus. That is for one water molecule. One water molecule, you will get half H2 and one OH minus. Two water molecules means one H2, two OH minus. So by taking this one, you will get hydrogen gas plus 2 OH minus. I will keep this one also as a side note. That is a memory technique, Nana. That means if you don't use memory technique, sometimes you don't get this one. Okay, now you tell me. Na plus is still there. Okay, hydrogen is getting reduced, Baba. I am here, cool. I don't want to react. I am already satisfied with electric gas configuration. Na plus is almost like a Baba. It won't do anything. It won't react. It's not having any desire to participate in chemical reaction. But here what happens? OH minus is coming in because of this one. So Na plus and OH minus we write as the sodium hydroxide. That's why what are the products? Therefore, that implies what are the cathodic products? Cathodic products. Cathodic products depends hydrogen gas and 2 moles of NaOH. Yes, you just finished this one, Nana. Okay, so I hope you got the reaction, Nana. So this is Kolbe's electrolysis mechanism, and I definitely feel I explained every bit of this mechanism, Nana. So once you understand this mechanism, one important note now, like in Wurtz reaction, that means Wurtz reaction, you cannot prepare methane. Methane cannot, if you take methyl chloride in Wurtz reaction, you start with methyl chloride in Wurtz reaction, you will get ethane. This is ethane, sodium in the presence of triether. So in Wurtz reaction, methane, if you want to prepare methane, cannot be prepared now. And also odd number of alkanes cannot be, that means, and also alkanes with odd number of carbons cannot be prepared now, cannot be prepared in Wurtz reaction. Same Nana here also exactly similar in Kolbe's reaction. So exactly in Kolbe's reaction also, you can't prepare methane because you just take an example. You started with the methyl group here, you are getting ethane. You cannot prepare methane. So in Kolbe's reaction also, methane cannot be prepared. Methane cannot be prepared. Now I am unable to prepare methane. Okay, Namma? If I want to prepare alkanes with odd number of carbon, that cannot be. I don't want to take mixture now. Sir, I want propane, sir, means you have to take here CH2, CH3, no? Different carboxylic acids. That is a bad idea. So don't take a mixture of reactants. No? So same thing. Also, I'll copy same thing. Exactly same thing. Because exactly same thing, I'm copying the sentence. Alkanes with odd number carbons cannot be prepared. Now, you got the Wurtz reaction. I will give this example number 2 as your assignment. For example, sodium succinate. Sir, what is the sodium succinate? Sodium succinate means succinic acid. Acetic acid, sodium acetate. Succinic acid. So what is the succinic acid? That is nothing but CH2COOH dicarboxylic acid. Dicarboxylic acids are very important. And dicarboxylic acid means it starts with oxalic acid. Oxalic acid is a dicarboxylic acid. So this is dicarboxylic acid. Okay, Namma? So dicarboxylic, a list of dicarboxylic acids can be remembered by using oh my such good apple pie. That mnemonic is there, memory technique is there. No, I'll discuss in the 12th class, not now. Okay. So that is dicarboxylic acid, succinate. Sodium succinate. Now I will write. So sodium succinate pen, this is a workout. That pen, this is for your practice. So this is the sodium succinate. Electrolyzed, two water molecules. So two water molecules means one HOH. I'm writing like this. I'm telling the memory technique. Okay. Electrolysis. The reaction is nothing but electrolysis. NaOH and NaOH, H2, COO and COO. Listen here, already bond is there now. One more bond, you will get one more bond. That means this is the beautiful way to prepare ethane. You can also prepare ethane now. Plus 2 moles of CO2 plus 2 moles of NaOH plus H2. You can easily memorize this one. Now you know the mechanism also. Once you know the mechanism, you feel confident. No, this is sir, would reaction also mechanism. Would reaction mechanism, I never seen in any kind of examination because would reaction mechanism is not well established now. So that is anode and cathode. Now I will give next example. Example number 3, sodium malate. Sir, what is this, sir? Sodium malate. What is this malate? Malonic acid. Malonic acid. Okay, I will do one thing. And why this much? I will write this one in a next page now, so that it will be free to understand. So, malonic acid. I'm sorry, not. I'm really sorry. Maliate. So, malic acid, not. That is nothing but malic acid. So, what is this malic acid? CH double bond CH, and this is carboxylic acid, and this is carboxylic. This is also dicarboxylic acid. But observe that 2 bonds already there here. Okay. Sodium salt of malic acid is sodium malate. Sodium malate. So the sodium malate, CH double bond CH, sodium salt of this one. Okay. Na? So now this is nothing but CH double bond CH and C double bond O, ONA. I am taking the Kolbe's electrolysis for this one. I use the memory technique HOH and HOH. I go for the electrolysis. Okay. I'm going for the electrolysis means NaOH, and this is nothing but NaOH, H2 and CO2, and this is CO2. And you will get new bond here. That means already 2 bonds are there. You will get new bond. And CH, triple bond CH, plus 2 CO2, plus 2 NaOH, plus hydrogen gas. So this is nothing but anodic product. And what you get in? Acetylene. Commercially very important. Acetylene is ethane, acetylene, ethane. All these gases are very important commercial products. Ethane is cooking cylinder now. Ethane gas and acetylene. Ethane gas is used to ripening the fruits now. Okay, Namma? And acetylene. Acetylene is used in the oxyacetylene torch. All these are very commercial. Now, electrolysis process is the convenient process. It's a very convenient because it is convenient industrially. It is one way you can say easy process. Thermal process are very difficult now. Thermal process means heating the reaction mixtures. Okay, that is you have to maintain a lot of temperatures. Okay, using electricity is a lot better than the maintaining the temperatures. Right, Nana? Right. So that means you are getting. So what is this one? I think I written the name ethene here. I will also write the name of this compound. The name of this compound is ethyl, but popularly called as acetylene. Okay, Namma? Right. So this is what you have to understand in Kolbe's electrolysis. Nana. So I hope I given a full-fledged understanding of the Kolbe's electrolysis. Electrolysis techniques also again explained. I didn't assume you know the electrolysis. Again, I explained the electrolysis preference of discharge. Okay. I hope you got this one, right? So these are the two named reactions you have to understand well now. So next I am going for the very important, and you will get this one in the 12th class also. Actually, it is 12th class reaction, but I decided to discuss here itself. That is nothing but decarboxylation.